Hello class, this is a video tutorial on reciprocal of functions part 1. The reciprocal of a function y equals f of x is given as y equals 1 over f of x. Like all previous transformations, not entirely sure what to classify all these different changes to functions we can call them. These can all be graphed using a table of values. However, as we've seen in the previous transformations, I guess, it is best to understand the properties of the function in order to graph y equals 1 over f of x. So you could use a table of values, but as we'll learn in this, it's best to understand what is happening with reciprocal functions in order to graph them. A few important notes before we continue. You shouldn't confuse the reciprocal function y equals f of x to the power of -1 with the inverse of its function. So y equals f inverse of x. So these are not the same. Hyperbolic functions are of the form f of x over g of x. Reciprocal functions, though, the ones we'll be looking at in this video, are a subcategory of these. It's only that f of x is equal to a constant number k. In this case, k will be equal to 1. So later on, we're going to look at more complex hyperbolic functions. But for now, we're only going to be looking at k over f of x, more particularly 1 over f of x. And we'll learn how to do more complex ones later. So let's take a look at the features of, or the properties of reciprocals in order of difficulty to understand. So the most easy thing to understand comes here first, and the most difficult ones are later on here. So let's take a look. In y equals f of x, so the original function, when f of x is increasing, its inverse will be decreasing. If f of x is decreasing, sorry, not its inverse, its reciprocal will be increasing. Okay, so once again, f of x is increasing, its reciprocal will be decreasing. So it's vice versa. Any x-intercepts in the function f of x, that will become a vertical asymptote in the reciprocal. Now the reason for that is very simple. Let's say we had y is equal to f of 3, and there's an x-intercept at f of 3, so that would become y is equal to 0. Now for the reciprocal, it will become y equals 1 over f of 3, but since f of 3 is equal to 0, it will become 1 over 0. This is a undefined value, hence that will become a vertical asymptote. Any vertex of the form AB, so that's x, y, in the function f of x, will also become a vertex in its reciprocal. However, while the x values remain the same, its y value becomes reciprocal. So b becomes 1 over b. Expanding further on this, if it is a maximum in f of x, it will become a minimum in the reciprocal. And vice versa, if it's a minimum in the function f of x, it will become a maximum in the reciprocal. And lastly, this last point only applies if f of x is a polynomial. As f of x approaches plus and minus infinity, so it goes off further to the right and the left, the reciprocal is approaching 0. This is just another way of saying that there is a horizontal asymptote of y equals 0. So now, using all of these points without using a table of values, let us sketch the let's sketch the reciprocal y equals 1 over f of x. So let's do it here. Now, looking at these points, let's actually, well, I encourage you to look at this point first because it's the easiest one to find. So let's find any x-intercepts in the function. Well, in the function, I can see two x-intercepts, one here. Let's make this into dots. Let's give it a different color so we can see it a little bit better. And one here and another here. So we have two vertical asymptotes at those 2 points. At x equals 3, let's write that in. At x equals 3 and at, negative 3, and at x is equal to positive 1. There's also a horizontal asymptote. Now, this is a regular polynomial. It's just a parabola. So there's a horizontal asymptote. Let's do it in red so we can see it. At y is equal to 0. Oops, not quite perfectly there. There we are. Let's make it into a dotted line so we can see it. So we've finished 2 points already. We finished this one here and this one here. Let's take a look at the vertex of f of x. We can see a vertex here at -1, -4. This will also become a vertex in the reciprocal. Its x value will remain as -1, but its y value, will become a reciprocal of -4. So -1/4. So plotting that point, that looks to be approximately here. There we are. And not only that, because maximums in f of x become minimums in the reciprocal and vice versa. So minimums in f of x become maximum in the reciprocal. Since this point is a minimum, it will become a maximum in its reciprocal. So it should look, I hope you can already imagine it, should already look something like this in your mind. So it should definitely be doing something like this. All right? Okay, so it should look something like that. So we finished with this point here. Now, this is the last point that's rather tricky to get your head around. But generally speaking, it'll look something like this. Notice how in the function f of x, it is decreasing here that I've highlighted. Since it is decreasing, its reciprocal should be increasing. Okay, not only that, because we said that this last point, as x approaches -infinity, its reciprocal is approaching 0. So it should be a horizontal asymptote like this. Let's try and make it as close as we can, like this. So there's a horizontal asymptote like so. And now let's consider what's happening as we get closer and closer to this asymptote. Well, as we get closer and closer, let's, for example, let's take this point here. This is a y value of 5. In its reciprocal, it'll become 1/5, so 1/5. Oh, just realized we can make this asymptote even closer, like this, because 1/5 is something like that. So it should be curving a teeny tiny amount like this. Now let's take a look at this point. This point is y equals 2. Its reciprocal will become half. So take a look here. This is 5. Its reciprocal at that same point would be 1/5. This point here is a y value of 2. Its reciprocal will be 1/2. So half. So it should be something like this. Now consider what's happening again as we move closer. At this point here, it's 1. So it's reciprocal 1/1. will be 1, so it should do something like this. And now, as it gets really close to 0, let's say we pick a point very close to 0, let's say it's over here, let's say that's half. 1 over half, 1 over 0.5, well, that becomes 2. So it should become something like that. Let's pick a point even closer to 0, so 1 over 0.1, well, that becomes 10. So it skyrockets all the way up there. So I hope you can already see what's happening with this vertical asymptote. Well, this vertical asymptote should be super close, like that. It should shoot off to positive infinity, like so. So on the left hand side, in blue, I know it's, hopefully you can see it. In blue you can see it, I'm highlighting it here. It should be something like that. The exact same thing should occur on this right hand side, should be near identical. So let's actually graph that out. And just to kind of cheat, because I've got an iPad, I can now just draw a straight line. No one will know that that is getting closer and closer. And likewise with this, should curve upwards like so, and then shoot up because it is a vertical asymptote, like so. I'm drawing it as a vertical line, but it should really be getting closer and closer, but it's hard to draw that. So we've drawn this right hand side, this left hand side. Let's now focus on what's going on in the middle here. Well, hopefully you can already see it actually. This point here is -1. So 1 over -1, its reciprocal is going to be -1. So it should actually be something, should be wide enough, like so. Right? And then from here, it should look to be something super close, because it is indeed a vertical asymptote. So it should be close, something like that. Hopefully you understand the general idea, because it's really hard to sketch these accurately. And there we have our sketch. So more exaggerated, so what I'm about to show you is definitely incorrect. So it should look something like that. That's me exaggerating what's going on. But in blue, closer to the lines, is what it should really look like. So I hope that gave you an insight into sketching reciprocals of functions. Hope to see you in the next video where we do a few more examples of this. Hope to see you then. Best of luck.